If Earth stopped spinning while you slept, you wouldn't wake up. Not because you'd be dead, though billions would be, but because morning wouldn't come. The sun would freeze in the sky, half the planet locked in eternal daylight, the other half in endless night. Within hours, supersonic winds would scour the surface. Within days, tsunamis would reshape continents. Within weeks, only a thin band of twilight would remain habitable, and anyone who survived would face a question: how do you live on a planet that no longer turns? Tonight, we'll explore exactly what happens when Earth's rotation stops. Second by second, hour by hour, day by day, some of the answers might surprise you, some might disturb you, but all of them will make you appreciate the world as it is. Let's begin. But first, let's understand what we're actually talking about. Right now, you're moving very fast. Even if you're lying completely still, you're traveling at over 1,000 kilometers per hour. Earth rotates on its axis once every 24 hours. At the equator, the surface moves at approximately 1,670 kilometers per hour. That's faster than the speed of sound, faster than a bullet train, faster than most fighter jets. As you move toward the poles, this speed decreases. At 45 degrees latitude, about halfway between the equator and the pole, you're moving at roughly 1,180 kilometers per hour. Still incredibly fast. At the poles themselves, you're barely moving at all, just rotating in place, like standing on a merry-go-round's center while the edge spins around you. But you don't feel any of this movement. Why? Because everything around you is moving at exactly the same speed. The air you breathe, the ground beneath you, the oceans, the clouds, every object, every person, every molecule of atmosphere. It's like being inside a perfectly smooth train, traveling at constant speed on perfectly straight tracks. If there are no bumps, no turns, no acceleration or deceleration, you can't tell you're moving at all. You could pour water, toss a ball, walk around normally. Everything behaves as if you're stationary. This is why we don't feel Earth's rotation. We're not just on Earth, we're moving with it, part of it. But what happens if that motion suddenly stops? Think about that train again. Now imagine it hits a wall, instantly. No gradual slowing, just stop. Everyone and everything inside the train keeps moving forward, violently. This is inertia, Newton's first law of motion, discovered over 300 years ago, but still perfectly accurate. An object in motion stays in motion unless acted upon by an external force. The train stops. The people inside don't. They're thrown forward at whatever speed the train was traveling. Now scale that up to Earth. The planet stops. But everything on the surface, everything not firmly anchored to bedrock, keeps moving at over 1,000 kilometers per hour. The atmosphere, the oceans, loose soil, trees, buildings, animals, people, everything. Let's see what this actually looks like. The moment Earth stops spinning, most of humanity dies instantly. You're in bed, asleep. The ground beneath you stops. But your body doesn't. You're moving east at 1,670 kilometers per hour, Depending on your latitude, you're thrown through your bedroom wall, through the house next door, through buildings, trees, anything in your path. It happens faster than thought. One moment you exist, the next you don't. No pain, no awareness, just instant obliteration. But let's imagine, hypothetically, that you're at one of Earth's poles. The North Pole or South Pole, where rotational speed is nearly zero. You might survive the initial stop. What would you witness? First, the wind. The atmosphere doesn't stop with the ground. Air has mass. It has momentum. When the surface stops, the air keeps moving. At the equator, winds instantly reach 1,670 kilometers per hour. That's Category 5 hurricane winds multiplied by 5. That's faster than the strongest tornado ever recorded. That's winds that would make a normal hurricane look like a gentle breeze. These winds don't just blow, they scour, they obliterate. Imagine standing in front of a sandblaster. Now imagine that sandblaster is the size of a continent and firing at 5 times the speed of sound. Everything on the surface is picked up and thrown eastward. Soil, rocks, trees, buildings, cars, everything becomes a projectile. Within seconds, forests are flattened, not bent, not damaged, completely torn from the ground and hurled away. Cities disappear, skyscrapers, built to withstand normal winds, shatter like glass. The rubble doesn't fall, it flies at supersonic speeds. Mountains are eroded, not over millions of years, in minutes. The surface layer, loosened by wind and debris, is stripped away down to solid bedrock. And the sound is beyond imagination. It's not just wind noise, it's the roar of the entire atmosphere moving as one, combined with the sound of continents being destroyed, buildings collapsing, mountains crumbling. The sound would measure over 200 decibels. For reference, a rocket launch is about 180 decibels. A volcanic eruption, 160. Normal conversation, 60. At 200 decibels, sound itself becomes deadly. The pressure waves can rupture organs, cause immediate hearing loss, kill through vibration alone. But you wouldn't hear it for long, because then cuts the ocean. Earth's oceans contain 1.335 billion cubic kilometers of water. That's 133 trillion liters. More water than the human mind can truly comprehend. All of that water is currently moving with Earth's rotation. The Pacific Ocean alone contains about half of Earth's water, and it's moving east at over 1,000 kilometers per hour. When the ground stops, the water doesn't. Imagine the largest tsunami in recorded history. The 2004 Indian Ocean tsunami had waves 30 meters high and killed 230,000 people. It was caused by an underwater earthquake that released energy equivalent to 23,000 Hiroshima atomic bombs. The tsunami from Earth stopping would make that look like a ripple in a bathtub. We're not talking about a wave. We're talking about the entire ocean moving inland. The Pacific Ocean, 165 million square kilometers of water, slams into the western coasts of North and South America, a wall of water hundreds of meters high, moving at over 1,000 kilometers per hour, carrying with it the debris of the ocean floor, ships, sea life, everything. It doesn't stop at the coast. It keeps going. Across North America, over the Rocky Mountains, across the Great Plains. In flat areas, it travels hundreds of kilometers inland before finally slowing. The Atlantic Ocean crashes into Europe and Africa with the same force. Portugal, Spain, France, the United Kingdom, all submerged under moving ocean. The Indian Ocean engulfs India, Southeast Asia, Australia's western coast. Every coastal city on Earth is erased in the first hour. Not damaged, erased, no trace left. Billions of people gone in minutes, but the destruction doesn't end there. After the initial surge, the water has to go somewhere. It can't just pile up indefinitely, so it flows. Low-lying areas become new seas, river valleys become straits, mountain ranges become islands. The Netherlands, already below sea level, is completely submerged. The Amazon basin becomes an inland sea. The Mississippi River Valley floods from Louisiana to Minnesota, and the water is not clean. It's carrying debris, rubble from destroyed cities, chemical pollutants from industrial areas, bodies, wreckage. Within hours, Earth's geography is unrecognizable. Let's imagine, impossibly, that you survived. You were in exactly the right place, deep underground in a hardened bunker, or somehow sheltered from both wind and water. What happens next? The initial supersonic winds begin to slow, not because conditions are improving, but because the momentum of the atmosphere is being absorbed by friction with the surface and by the massive turbulence of air masses colliding. But the winds don't stop. They reorganize into massive, chaotic circulation patterns. On normal Earth, rotation creates the Coriolis effect. This effect makes moving air curve. It's why hurricanes spin. It's why weather patterns move in predictable ways. It's why winds circle around high and low pressure systems instead of blowing straight. Without rotation, there's no Coriolis effect. Weather patterns as we know them cease to exist. Instead, you get something much simpler and much more violent. The day side of Earth, still facing the sun, begins heating up. Remember, without rotation, the same side faces the sun permanently. No sunrise, no sunset, just endless noon. The night side begins cooling down. Without sunlight, without rotation to bring warm air from the day side, temperatures plummet. Within hours, the temperature difference becomes extreme. The day side reaches 40, 50, 60 degrees Celsius in some areas. The night side drops to minus 40, minus 50, minus 60 degrees Celsius. Hot air rises on the day side, cold air sinks on the night side. This creates a massive convection cell. Air flows from night to day near the surface, rises on the day side, flows from day to night at high altitude, then sinks on the night side and repeats. But without the organizing force of rotation, these flows are chaotic, turbulent, unpredictable. Massive storms form where hot and cold air meet. These aren't like normal storms. They don't spin. They don't have organized structure. They're just violent collisions of air masses with drastically different temperatures. Lightning flashes constantly, not from normal thunderstorms, but from the intense static electricity generated by turbulent air movement. And the rain. On the day side, the oceans that remain are evaporating rapidly under constant sunlight. Water vapor rises into the atmosphere. When it reaches the upper atmosphere and cools, it condenses. Massive rainstorms form. Not brief afternoon showers, continuous, unending rain, months of rain, years of rain. The day side begins to resemble Venus, hot, wet, thick atmosphere, low visibility, constant storms. On the night side, any remaining moisture freezes. It falls as snow. Thick, heavy snow. Meters accumulate within days. The night side becomes an Arctic wasteland, dark, frozen, silent. And at the terminator, the boundary between day and night, conditions are almost habitable. The sun sits on the horizon, perpetual sunset on one side, perpetual sunrise on the other. The temperature is moderate, 10 to 20 degrees Celsius, depending on local conditions. If any humans survived, they'd migrate here, to this narrow band, perhaps a few hundred kilometers wide, circling the entire planet. This is the new habitable zone, eternal twilight. Now let's talk about what happens to the oceans over the following days and weeks. After the catastrophic initial tsunami, you might expect the water to settle back into the ocean basins. But that's not what happens. Earth's shape is not a perfect sphere. It's an oblate spheroid, slightly flattened at the poles, slightly bulging at the equator. Why? Because of centrifugal force from Earth's rotation. When something spins, objects on it experience an outward force, like when you're on a merry-go-round and feel pulled toward the edge. That's centrifugal force. Earth has been spinning for over 4 billion years. Over that time, the planet has deformed. Rock is solid, but on geological timescales and under immense forces, it flows like a very slow liquid. The result is that Earth bulges at the equator. The distance from Earth's center to the surface is about 21 kilometers greater at the equator than at the poles. The oceans have deformed too. Water is much more fluid than rock. There's significantly more water at the equator than there would be if Earth didn't spin. About 8 kilometers more depth. When Earth stops spinning, centrifugal force disappears instantly. That equatorial bulge is no longer held in place. Gravity takes over. Water begins flowing toward the poles. Not all at once, gradually, over days and weeks, but inexorably. The equator loses water, a lot of water. Seafloor that has been underwater for millions of years becomes exposed. Islands grow, archipelagos connect, new land masses appear. Indonesia, currently thousands of separate islands, becomes a connected landmass. The Caribbean islands merge. The Pacific islands grow and link together. A new continent emerges around the equator, a ring of land circling the globe. Meanwhile, the poles gain water. Deep water, the Arctic Ocean, already deep, becomes much deeper. The Southern Ocean surrounding Antarctica deepens dramatically. Antarctica itself, currently a continent, becomes partially submerged. The ice sheet remains, but the land beneath is now underwater in many places. Within weeks, the map of Earth looks completely different. Two massive, deep polar oceans, a shallow sea around the equator, and new land masses where there used to be only scattered islands. Any marine life in these redistributing oceans faces catastrophe. Fish adapted to warm tropical shallows suddenly find themselves in deep, cold polar waters. Species adapted to polar conditions are displaced or drowned by the incoming water. Coral reefs, already stressed, die as water depth and temperature change. Kelp forests, which depend on specific depth and light conditions, wither. And ocean currents, which on normal Earth distribute heat and nutrients around the globe, collapse. On a spinning Earth, currents are driven partly by wind and partly by the Coriolis effect. The Gulf Stream, for example, carries warm water from the Caribbean to northern Europe, making Europe much warmer than it would otherwise be. Without rotation, these currents cease. The oceans become stratified. Warm, less dense water sits on top. Cold, dense water sinks to the bottom. No mixing, no circulation. This is catastrophic for ocean life. Nutrients from the deep ocean, essential for plankton growth, no longer reach the surface. Plankton populations crash. The entire marine food web collapses from the bottom up. Within months, the oceans are dying. Let's examine each side of the planet more carefully. The day side. The sun never moves. It hangs in the sky, perhaps directly overhead, perhaps at an angle, depending on the season, when rotation stopped, but fixed. Unmoving, eternal. Hour after hour, day after day, the sun beats down on the same patch of Earth. Temperatures rise relentlessly. In the first week, some areas reach 60 degrees Celsius during local noon, though of course it's always noon now. After a month, temperatures in the hottest areas exceed 80 degrees Celsius. That's hot enough to kill most plants, hot enough to make mammalian life impossible without constant access to water and shade. Water evaporates rapidly. Lakes shrink visibly day by day. Rivers slow to trickles, then dry beds. The soil bakes hard, cracking into polygons as moisture leaves. Plants begin dying immediately, not just from heat, but from disrupted biological rhythms. Many plants require day-night cycles to regulate photosynthesis, to flower, to grow properly. With constant light, these mechanisms fail. Some plants keep photosynthesizing until they exhaust their resources and die. Others shut down entirely, unable to cope. Trees wilt. Grass browns. Forests become graveyards of dead wood. Animals suffer. Mammals, which regulate body temperature internally, overheat rapidly without the cooling relief of night. Many die within days. Reptiles, better adapted to heat, last longer, but even they have limits. At 80+ degrees Celsius, proteins denature. Cell structures break down. Birds attempt to fly toward cooler areas, but there are no cooler areas on the day side. Some fly toward the poles, toward the terminator. Many die in flight, exhausted, overheated. Insects, more resilient to temperature extremes, survive longer, but without plants, without the ecosystems they depend on, they too begin dying off. The day side becomes a desert, but worse than any desert on normal Earth, because deserts cool at night. This doesn't. After months, surface temperatures in the hottest areas may reach 100 degrees Celsius. Boiling point. Any remaining surface water exists only as steam. The day side is hell, literally, an inferno without end. The night side, the opposite extreme. The sun never rises, darkness is total and permanent. Without sunlight, photosynthesis stops immediately. Every plant on the night side dies within weeks, maybe days for some species. Temperatures drop rapidly. On a normal Earth night, the ground and atmosphere cool slowly, retaining some heat from the previous day. But that equilibrium depended on the sun returning every 24 hours. Now it doesn't return. The first night, temperatures drop to normal nighttime lows, maybe 10 to 15 degrees Celsius in temperate regions. The second day, though there is no day, they drop further, maybe 0 degrees. Freezing by the end of the first week, temperatures in many areas have dropped to minus 30 degrees Celsius. By the end of the month, minus 60 degrees Celsius in some places. Colder than Antarctica in winter. Water freezes solid. Lakes become blocks of ice. Rivers freeze from the surface down, eventually becoming solid ice throughout. The ground itself freezes. Permafrost forms, but much more extensive and deeper than on normal Earth. In some areas, the ground is frozen meters deep. Any animal life faces two problems: extreme cold and total darkness. Mammals with fur can survive cold. Arctic foxes, polar bears, snow hares, they're adapted for it, but they need food. And without plants, without the food web, there's nothing to eat. Some animals attempt to migrate toward the terminator, toward the twilight zone. But it's far, hundreds or thousands of kilometers for most. Many die before reaching it. The night side becomes a frozen wasteland. Silent, dark, dead, snow falls, but it's not normal snow. With no warmth to create the convection needed for normal snowfall, precipitation occurs differently. Moisture freezes directly out of the air, forming frost and ice crystals that slowly accumulate. After months, the night side is buried under meters of ice and frost. The landscape becomes unrecognizable. Hills and valleys smoothed under blankets of frozen water. It looks like the dark side of a frozen moon, lifeless, airless seeming, though air remains. Just cold, still, dead. The terminator, between these two hells, a thin strip of habitability remains. The terminator is the boundary between day and night. On normal Earth, it's constantly moving as the planet rotates. The line of sunset moves west. The line of sunrise moves east. But on a stopped Earth, the terminator is fixed. A permanent boundary circling the planet. The sun sits on the horizon. If you're on the day side edge of the terminator, you see eternal sunset. If you're on the night side edge, eternal sunrise. The light is angled, soft, like the golden hour that photographers love, but lasting forever. Temperatures are moderate. Heat from the day side, cold from the night side. They meet and balance. The result is a zone that's 10 to 20 degrees Celsius, habitable, barely. But it's not peaceful. The Terminator is where hot dayside air meets cold nightside air. This creates constant, violent weather. Winds blow continuously from the dayside toward the nightside, near the surface, driven by pressure differences. These winds can be strong, sustained 50 to 100 kilometer per hour winds. Storms form constantly. Thunderstorms, not brief afternoon showers, massive, semi-permanent storm systems that sit at the boundary between hot and cold. Rain falls frequently. Water evaporated from the dayside oceans condenses here. The Terminator is perpetually wet. Lightning flashes day and night. Well, there is no day and night here, but constantly. The electrical display is spectacular, but dangerous. Living at the Terminator means living in a perpetual storm. Windy, wet, lightning-filled, but it's survivable. And if any humans made it through the initial catastrophe, this is where they'd be, building shelters, trying to grow food in the dim, angled sunlight, collecting rainwater, surviving. It would be a hard existence, but existence nonetheless. Now we need to talk about something most people never think about: Earth's magnetic field. You can't see it, can't feel it, but it's there, surrounding the planet like an invisible shield. This magnetic field protects us from solar wind, a constant stream of charged particles flowing from the sun. Without the magnetic field, these particles would bombard the Earth's atmosphere directly, stripping it away over millions of years. This is what happened to Mars. Mars lost its magnetic field billions of years ago, and solar wind gradually stripped away most of its atmosphere. But how is Earth's magnetic field generated? Deep inside Earth, about 3,000 kilometers down, is the outer core. It's made of liquid iron and nickel, heated to thousands of degrees Celsius. This liquid metal moves. Convection currents, driven by heat from the even deeper inner core, cause the liquid to flow in complex patterns. And crucially, Earth's rotation affects these patterns. The spinning of the planet creates a phenomenon called the dynamo effect. The rotating, electrically conductive liquid generates magnetic fields, which combine to create Earth's overall magnetic field. If Earth stops spinning, does the magnetic field disappear immediately? No. The outer core has enormous mass and momentum. It won't stop instantly just because the surface does, but over time, weeks, months, the convection patterns that depend on rotation begin to break down. The magnetic field weakens, first by 10%, then 20%, then 50%. Within a year, it might be gone entirely. What happens then? Solar wind, normally deflected toward the poles, where it creates the beautiful auroras, now hits the atmosphere everywhere, all the time. This has several effects. Effect 1. Increased radiation. Cosmic rays and solar particles that were previously deflected now reach the surface. Not enough to kill you instantly, but enough to significantly increase cancer rates. Any surviving life at the Terminator would face higher levels of radiation. Plants would accumulate more DNA damage. Animals would develop cancers more frequently. Human survivors would see cancer rates skyrocket. Spending time outdoors would become more dangerous. Shelters would need to be underground or heavily shielded. Effect 2. Atmospheric erosion. Solar wind particles hit atmospheric molecules and knock them into space. Normally, this happens only in small amounts at the poles. Now it happens everywhere. The atmosphere begins to thin, slowly at first, imperceptibly, but over decades and centuries, the effect compounds. Within 1,000 years, Earth's atmosphere might be noticeably thinner. Within 10,000 years, significantly thinner. Eventually, Earth could end up like Mars. A thin atmosphere, low pressure, unbreathable, but that's far future. For any survivors in the first years, the immediate concern is radiation, not atmospheric loss. Effect 3. The night sky changes. Auroras, those beautiful lights caused by solar wind particles being channeled to the poles, disappear. But something else appears. The zodiacal light, normally a faint glow caused by sunlight reflecting off dust in the solar system, becomes much more prominent. Cosmic rays, no longer deflected by the magnetic field, rain down on the atmosphere. When they collide with air molecules, they create flashes of light, faint but visible. The night sky, or rather the Terminator's eternal twilight sky, fills with strange lights, streaks and flashes from cosmic rays, bright bands from the zodiacal light. It's beautiful in a way, but ominous, a visible reminder that Earth's protective shield is failing. Could humans survive this? The honest answer is almost certainly not in large numbers. The initial catastrophe, the winds, the tsunamis, would kill 90% or more of humanity in the first day. Billions dead within hours. But let's imagine a few thousand survivors. People who were in exactly the right places. Deep underground bunkers built to withstand nuclear war. Research stations in remote areas. Submarines at sea that somehow avoided the worst of the tsunamis. What would they face? Immediate survival needs. Air, not an immediate problem. Even with atmospheric changes, there's still breathable air. Water, critical. Surface water on the day side is evaporating. Surface water on the night side is frozen. The best sources would be at the Terminator, where rain is frequent, or deep underground wells. Food. This is the big problem. Agriculture as we know it is impossible. No crops can grow on the day side or night side. At the Terminator, maybe some hardy plants could survive in the dim sunlight, but productivity would be low. Survivors would rely initially on stored food, canned goods, freeze-dried supplies, but these run out. Hunting is not an option. Most animals are dead. The few survivors are scattered and difficult to find. The only viable long-term food source is controlled environment agriculture, greenhouses with artificial lighting, hydroponics, algae farms. This requires energy, a lot of energy. Energy sources, solar panels work on the day side, but they'd need to survive the extreme heat, and you'd need to be able to access them, which is dangerous. Wind power could work at the Terminator, where winds are constant, but maintenance would be difficult in the perpetual storms. Nuclear power is the best option. A few survivors with access to a functional nuclear power plant could generate electricity for years. But nuclear plants need maintenance, skilled operators, spare parts. Eventually, even these run out. Geothermal power is another option, drilling deep to access Earth's internal heat. This is sustainable long term, but requires significant infrastructure to set up. Shelter. At the Terminator, survivors would need shelter from constant wind and rain. Buildings, but reinforced against storms. Or underground complexes. Underground is actually ideal for multiple reasons. Protection from radiation, stable temperatures, protection from weather. Imagine a community living in an underground complex at the Terminator. Tunnels connecting living areas, farms, workshops. Power from geothermal or a small nuclear reactor, water from the frequent rain collected and filtered. Life would be difficult, confined, every resource precious, every failure potentially catastrophic. Psychology, living in eternal twilight, knowing that in one direction is endless scorching day and in the other endless frozen night, would be psychologically challenging. Depression rates would be high. The stress of mere survival, the loss of almost everyone you knew, the knowledge that this is permanent, that Earth will never return to normal. But humans are adaptable, resilient. Communities would form, maybe small settlements of a few hundred people, maybe just scattered groups of a few dozen. They'd develop new cultures, new ways of living, maybe new beliefs, with the sun on the horizon becoming a religious symbol. Over generations, these survivors would become something different from us. Not genetically, perhaps, but culturally, adapted to a world we can barely imagine. Long-term evolution. If humanity survived for thousands of years, would we evolve? Probably not physically. Evolution requires large populations and many generations. With only thousands of survivors, genetic drift would be more significant than selection. But cultural evolution would be rapid. New skills would be valued. Understanding of renewable energy, agriculture in controlled environments, water management, radiation protection. These would become the most important knowledge, passed down carefully, guarded, essential, and perhaps eventually, if the population stabilized and grew, real biological evolution could begin. Adaptations to the constant twilight, better radiation resistance. Who knows what humans might become in 10,000, 100,000 years? But that's speculation far beyond what we can reasonably predict. So what have we learned from this journey? We explored what would happen if Earth stopped spinning. We saw immediate catastrophe, supersonic winds, continent flooding tsunamis, billions of deaths in the first hours. We saw the reorganization of the world, oceans redistributing, the day side becoming a scorched wasteland, the night side becoming a frozen desert, the Terminator becoming the only habitable zone. We saw the collapse of the magnetic field, increased radiation, atmospheric erosion, the slow transformation of Earth toward a Mars-like state, and we saw that human survival, while technically possible, would require living in ways completely alien to how we live now. But underneath all of this, there's something deeper. This scenario reminds us how fragile everything is, how dependent we are on things we never think about. We don't think about Earth's rotation. It's just there. constant, reliable. The sun rises, the sun sets, day follows night, seasons change. But these aren't guaranteed features of reality. They're the result of specific physical conditions. Earth spinning at a specific rate, tilted at a specific angle, orbiting the sun at a specific distance. Change any one of these variables, and everything falls apart. We like to think we're in control. We build cities, we shape the landscape, we seem powerful, but we're not. We're passengers on a planet spinning through space. We survive because the conditions happen to be right. Temperature, atmosphere, water, magnetic field, rotation, tides, seasons. Take away anyone and we're helpless. This isn't meant to be depressing. It's meant to be humbling, and hopefully it creates appreciation. Right now, Earth is spinning. The sun rises every morning and sets every evening. Oceans stay in their basins. The magnetic field protects us. These things aren't magical. They're physics. But they're also precious. And we should appreciate them, protect them, because we depend on them more than we usually realize. Earth spinning at 1,670 kilometers per hour isn't a problem. It's a gift. It creates our days and nights. It drives our weather. It generates our magnetic field. It makes life as we know it possible. If it stopped, we'd die. Not because we're weak, but because we're adapted to the world as it is. And maybe that's okay. Maybe being adapted is what life is about. Finding a way to survive in whatever conditions exist. Appreciating those conditions while they last. Because nothing is permanent. Not planetary rotation, not magnetic fields, not even continents or oceans. Everything changes eventually, but right now, in this moment, Earth is spinning, the sun is rising and setting, the seasons are changing, and we're here to witness it. For now, that's enough. Good night, and may your dreams be filled with gratitude for the world that keeps turning.